Hello there, I'm Thomas Hatsios, a German-American pilot flying Boeing 787-900 to night flight. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449, let's localize the landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings. Boeing 787-900 Microsoft Simulator X. I'm going to start showing you the cockpit displays and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. The display is the airspeed indicated. The airspeed selected from the autopilot flight director system panel, ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the vertical rate of flatness of the aircraft, and 100,000 feet per minute. All the steepness of the econometric angles decrease. It can climb the descent. We have also the altitude indicator with the artificial horizon, the pitch ladder in degrees, and the bank angle in degrees, the Lszh localizer. We have the threshold ordinance of the runways we use for takeoff and for landing. So we can align with the horizontal localizer and vertical glide slope. We receive the onboard from the onboard antennas of the aircraft, the radio frequency transmitted from the threshold antennas of the runways we use for landing and for takeoff, and we have to tune the radio frequency for each runway we use, and also align with the magnetic north pole heading. So you're gonna see how we're gonna use that the Lszh localizer. This is my landing system. We have also the Lszh localizer. Crossbars, we have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode and actuator with the autopilot and the auto throttle. Later on vertical navigation modes, we have also the X-side, the horizontal situation indicator with magnetic heading and track, the integrated display of the flight plan. We have also the navigation display that displays the GPS position of the aircraft, the terrain and weather reflections from the weather radar. You can see the red, green, yellow color, amber color, and also see the lakes and the rivers with blue. So we can see depending on the distance the terrain is located away from the aircraft, and also the altitude difference of the aircraft with the terrain. We're gonna see different colors. Also we can see in the terrain map the airports where they are located, the airport maps, the runways and the taxiways we can use. We have also the airports. We have also the navigation aids, the nav aids, the workstations, ADFs, and the waypoints which are horizontal, vertical navigation fixes, and altitude and speed countries. We're gonna have to fly through some waypoints. You're gonna see later. I'm gonna use here the flight management computer. I will input all the data of this aircraft for this flight. So you're gonna be overflying some waypoints. You're gonna see the flight plan is gonna be created over here, and it's gonna be displayed in the navigation display, also in the HSI with a purple magenta line. You can see the terrain, red, green, yellow, amber color. You can see some airports here. So you can see the Düsseldorf airport, as you can see. So you can see DTL airport. You can see our own airport. Here is Lszh Zurich, and here is in front of us is the Düsseldorf DTL airport in Germany. So we look up in front. You can see the terrain in front of me, the mountains, and also we have the airport, the Düsseldorf, like 60 nautical miles away from us. You can see in the vertical display also the altitude difference when we fly, the distance. Also you're gonna see later as we progress. I'm gonna start with the primary flight display. So you can see also in the navigation display, you can see other aircraft that fly around our own aircraft using the transponder. They display AC transmitter receiver that transmits radio frequency to other aircraft in the air traffic control and receives from other aircraft. You can display the other aircraft position. You can calculate with this computer the altitude difference, how many hundreds and thousands of feet the other aircraft is above or below our aircraft, whether the climb or descent with respect to our aircraft. Also you can calculate the velocity closing in between our aircraft and the other aircraft. Will give us a warning if we have an incoming collision in the air. We will make an avoidance maneuver using the TICA system, the traffic collision and advisory system of the aircraft. So this is the navigation display. You can see other aircraft with the diamond shape and the altitude difference, whether the climb or descent. So we have an incoming aircraft right now. You can see here is spotted. Also through the head-up display, you can see over here is coming for landing, so we're gonna see that in a couple of minutes. I will progress with the rest of the system. You will see also the flight controls of the aircraft, how I'm gonna use the flight controls to control the Boeing 787. So I have the side stick here for climb and descent to make turns left and right. Use the control column, also the rudder pedals of the aircraft, the thrust levers, and the horizontal tail trim stabilizer. So you can see like this, we can climb the aircraft, we can descend, we can make turns right and left. I have the side stick connected, and I can move the yoke here of the Boeing 787, the control column, as you can see, and the control wheel, also the rudder pedals. You can see the rudder pedals is used to control the vertical rudder. Also we have the nose wheel steering here, which is also interconnected with the rudder pedals in the ground automatically at some airspeeds. So you're gonna see also the thrust levers here, the pedestal, the instruments, the overhead panel. Also we're gonna start the engines. I'm gonna show you how we're gonna use the overhead panel. So you can see an aircraft is coming for landing in a couple of seconds. It's a Boeing 737-800. It's a spotted. It's a touchdown, as you can see. So you can see here we have the flight controls. So we can climb like this, control the elevator, the horizontal elevator, climb, descend, also the rudder, use the rudder pedals, and the ailerons and the spoilers, the left and right turns. We have the flaps extended, so this is the control axis. You can use also the horizontal stabilizer trim for the elevator when climbing, descend. You can see the APU here, the auxiliary power unit. So now we have the speed brakes are extended, and the flaps extended. So we control the ailerons and the flight spoilers like this, and also the elevator like this. Also we have the horizontal tail trim stabilizer. We can trim the elevator of the aircraft as we fly for climb, descend, to balance the aircraft in flight. Also we can fly with the hands off. So I will show you how to control the horizontal tail trim stabilizer before we go into this flight. So you're gonna see here, you can see we have these trim switches. We can trim the elevator up or down like this. So this way we trim the elevator up, pitch the aircraft nose up. This way we trim the elevator down, pitch the aircraft nose down. As you can see, very easy, very simple to use. So this way trim the elevator up, pitch the aircraft nose up. This way trim the elevator down, pitch the aircraft nose down. Also the control wheel, we can make turns like this, as you can see, using control wheel, climb and descend like this, push it back and forth. Also the rudder pedals, we have the vertical tail rudder, and also the nose wheel steering in the ground, interconnected with the tiller. Also we have here, you can see the stabilizer trim position is displayed over here in this switch. Stabilizer trim, we have the stabilizer trim. You can see the position right now is 4.85 degrees set for takeoff. We have the maximum and the minimum limit. The rudder trim, the flaps, also the cabin pressurization of the aircraft. You can see it displayed here. When we climb or we descend, the rate of climb and descend, differential pressure between the inside and the outside atmosphere, and also the outflow valves. You can see the engines indications. I will talk to you about the left and the right engine indication. You can see here we have the N1, which is the low speed starters, have low pressure compressor and turbine of the turbofan, with the engine, the exhaust gas temperature, and 2, which is high speed starters, have high pressure compressor and turbine of the turbofan, with the engine, fuel flow burns per 1,000 kilograms or thousands of pounds. Oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine, gross weight for takeoff, fuel temperature, and the total fuel on board the aircraft right now over here displayed. Also the landing gear, extend or retract, right now is down position. So we have here is the flight management computer, stabilizer trim. You can see also we have this trim position here. We can trim the elevator up and down, climb, descend the aircraft. We have also the cutoff switch for the left and the right, stabilizer trim. So this is in case we have some failure, we have to disconnect the auto trim function, the auto trim motor to the left or the right. You can see here the stabilizer of the aircraft, horizontal stabilizer. So if we disconnect this, open and disconnect, this is for all Boeing 737, Boeing 747, Boeing 757, 767, Boeing 777, Boeing 787. Open this red guarded switch from normal to cut off like this, and use only the alternate trim switch over here. You can see stabilizer trim, pitch trim, elevator up and elevator down like this. Also we have the parking brakes here, so you can see alternate pitch trim, nose up and nose down like this. We have also the fuel flow for the aircraft, left and right engine, the fire extinguishers, left and right engine, transporter, rudder trim, the thrust levers. So the thrust levers we use here have the thrust set, so we can increase or decrease the position of the thrust levers and actuate the thrust commanded by the engines in the idle position, for instance. Also the thrust reverse over here, as you can see. The auto throttle disengage switch, the takeoff go around over here, so this disconnects the auto throttle either side, thrust reverse, and this is the main function. We have also the flaps position here, the speed brakes like this. So you're gonna see all instruments before we go into flight. We have a couple more minutes. We're gonna make an engine start demonstration right now. In a couple of minutes I will show you a little bit more of the flight controls, and I'm gonna set the flight management computer. I will program a flight plan or a flight path or a route for this flight. So you can see here we have again the flight controls of the aircraft, as you can see. So we can climb like this, we can descend. You can see the side stick that I have. So climb, descend, make turns right and left, the rudder pedals, and now the stabilizer trim, also the thrust levers like this, thrust commanded. So this is the side stick that I have to control the aircraft flight control system. So we have also the outside view for this. So this is all for the flight controls right now. So I will show you now the flight controls. Now I will show you the flight management computer. I will input all the data we need for this flight. I will create a flight plan. Also it's going to be used by the autopilot. We will connect the autopilot. It's going to follow this flight plan. So you're going to see now how I'm going to use the flight planner of the aircraft. So we go in this view, as you can see. We're gonna use the flight management computer over here, so we use this view also. So you can see here we have you can see the mouse pad I can use to input the data. So you can see here the index, as it says: identity, position, performance, takeoff, approach, annunciate status, flight plans. So this is the regular flight management computer. Identity is a Boeing 787-900 GNX engines. As you can see, the index also has its position, so we can align the IRS, the inertial reference system, and Lszh airport. Over here you can see the coordinates, the longitude and the latitude of the aircraft. We go back to the index, performance, takeoff, zero fuel weight, fuel on board, gross weight, cruising altitude. So we set the route, first departure and arrival, Lszh airport, back to Lszh airport, copy paste like this, clear the discontinuity, runway 14. So we set departures like this. As you can see, departures, we select runway 10 14 16 2832. So we select runway 14 trans 0 to alpha. So we go in the arrivals, we select arrivals, runway 16 2834, ILS 14, ILS 16 GLS. So we select ILS 14 trans Amiki trans neg and the stars other terminal arrival waypoints and fixes. So this is the approach, Negria 1 alpha. So we have here, as you can see, so we have the departure, the route is created, and the arrival, we have to climb, cruise, descent, approach, and land. You can see one waypoint by another. So we set first zero fuel weight, fuel on board, cross weight for takeoff, reserve fuel, cruising altitude 25,300 feet over here, and we select the cost index 100%, fuel freezing temperature over here, minus 37 degrees, and the center of gravity in 5. So we press this green light, it will activate the route here. So we have an active route from takeoff, first waypoint, the airspeed and the altitude, then Zui 6 nautical miles, 302 knots, 6,000 above the sea level, then Negria 26 nautical miles from Zui, 302 knots, flight level 22,200, then make a right turn, heading 230, 12 nautical miles from Negria, descent approach over here, Amiki, Zui, Zurich 701, approach and landing over here, and also runway 14. So we have initialize, set the flaps for takeoff 15 degrees, center of gravity trim 33%, and the takeoff speeds over here V1, V rotate, V2 for this center of gravity and trim, and the runway position. So we have route, departure, arrival, alternate route, departure, arrival, alternate VNAV, progress, FMC communication, holdover, waypoint, the legs, and set radial fix, navigation radio here, tune ILS, localizer. So go back over here, we have a few more minutes to go for this flight. So we can see we have created the flight plan we needed to have over here. You can see displayed in the navigation display. I'm gonna show you now first the flight, how we're gonna set the APU, the auxiliary power unit, to start the engines. So we're gonna set this first on over here. I'm gonna see also the overhead panel. We can see the electric. So we set the start over here, left and right IDZ, 100 to 200 volts, 400 Hz frequency, primary flight control computers in the other position, air data computer, flight control surfaces over here, the battery, down bar, left door, over here, passenger oxygen, window heat, left and right engine driving, electric C1 and C2. So we start in the off position, and we start in the auto, and the on, and then to the auto position. And now the electric C1 and C2, we have the backup rammer turbine on the ice over here, in the on, and then to the auto position. Pressurization over here, alpha valves, family send the manual, then in the auto position. So we have pressurized air from the APU and the engines. We have the recorders, also cargo and APU fire, the electronic engine control for the left and the right engine with the auto start system. Over here we can start the engines like this later. I'm gonna show you how the fuel jettison, we get dump some fuel In flight, select the nozzles and how much fuel to remain. Also left and right over here, fuel booster pumps. The crossfeed valve input terminator to feed either engine with the other pump, and also balance the fuel between the left and right wing. Also feed either engine with other tank. So this is all we need for the overhead. You can see the pressurizer is used for cabin pressurization, wing and engine ADIs, air conditioning ventilation, oxygen, and also for the hydraulic fluid tanks pressurization here. We need pressurizer for all hydraulics from the engines or from the APU or a backer. So I'm gonna show you now the last thing that is left before we're gonna make an engine start demonstration. You can see here the displays. You can see more airports. Here you can see we have Germany, France, and Switzerland. The distance they are located away from our aircraft. Also the flight plan, vertical and horizontal. Look up closer. You can see this purple line is the flight plan we have to fly from takeoff, climb, cruises, and approach and landing. Also the runway here, the terrain elevation also. You can see the vertical display. The aircraft is in the ground right now. We're gonna be flying above the ground, so you're gonna see some mountains as we fly, and also the waypoints we have to cross through. If you look up closer, you can see better view of the mountains. You can see also the runway we're gonna use for takeoff, the taxiway. We have in front of us a taxiway, the runway, some mountains. So you can see from the GPS display over here the terrain and the runways, the airport information we need for navigating the airplane from one airport to the other. Also you can see the cabin, the pressurization here, the pressure of the outside atmosphere. We can see also the map of the airport like this, the whole airport map view like this. Also we have this display over here, map setting. This is the plan view. You can see the plan, a better view, the runway we're gonna use for takeoff and for landing, and now the flight plan, this purple line we're gonna follow. So we're gonna use now, we're gonna see the systems I show you in the overhead panel. You're gonna see all the systems one by one, the overhead panel systems. So you can see the hydraulics, APU, oxygen quality, and the liquid cooling over here. You can see here we have the electric, left and right the APU is running, the battery and APU battery voltage and average over here. The hydraulics, left and right engine driving, electric C1 and C2, shut-off valves, isolation valves. Over here 5100 psi the pressure and the quantity. So you can see where the which systems use of hydraulic fluid over here, where it goes, the fuel left and right, wing fuel tanks and air tank, the crossfeed valve is off. You can see low and high pressure fuel valves open and feed both engines, the total fuel on board. Also you can see the APU is fed from the left wing using the DC motor. You can see the minimum fuel temperature over here, below which the fuel will freeze in flight. So the FAREX that control the engine's function also control the fuel flow to the engines, and the display of the information you see here, the FAREX, the fuel authority, is the electronic control computer, one installed per engine. Gearbox also control the transfer of fuel in flight. When we fly at higher altitudes like 20, 30 or 40,000 feet above the sea level, they're gonna transfer automatically the fuel into the engine components to heat up the fuel, also the lubricant and the oil, and then transfer back the fuel into the left and the right wing or the center tank. So you can see here the minimum fuel temperature when we fly at higher altitudes is gonna be minus 37 degrees. So perhaps the fuel will freeze below that. So that's why we transfer. This is automatic. The fuel temperature right now is minus 6. You don't need to do nothing. There is an automatic transfer of fuel in flight. Also air pressurizer from the engines and from the APU. The doors are closed, the cabin can be pressurized, the gear, temperature of the brakes and pressure of the tires over here, as you can see. Flight controls over here. You can see the deflection of all flight controls, the wings, the tail, the rudder. So this is one of the last things we need to know before we go into flight. The flight controls system, F is display, maintenance, system and circuit breakers. So we have only the checklist is left before we go into flight. As you can see, normal menu, what to do before start, after start over here, takeoff, descent, approach over here, descent, approach and landing, as you can see. So this is the checklist we need to do. Normal checklist, as you can see. And also we have the communication, so we go back in the navigation display. Gonna see now the engine start demonstration. So we have a few more minutes to go into flight. The engine start demonstration. I'm gonna show you now how to restart the engines. I'm gonna turn off both engines off over here. Fuel flow in the off position. You can see now the engines are off. And now the message is coming up. So this is the Boeing 787. We need to restart very quickly. So the auto start here in the start position like this. So we have N2 exhaust gas temperature. We're gonna start the engines very quickly. You can see now the N2 is increasing, which is a high-speed pressure, high-speed cylinders have high pressure compressor into one of the turbocharged engine. There is a limit of pressurizer from the APU, from the auxiliary power unit. So we have only pressurizer. We can start above 23% the fuel flow, and we have the auto start coming up. So you see the auto start, and we have all systems of the engines now are working because we have both pressurizer and fuel. So it's gonna take a few more seconds. You can see now the message is going off. The auto start in the running engines at 61%. So we have one last thing, speed brakes arm, flaps set for takeoff, and we set only the autopilot now over here very quickly. You can see auto throttle left and right, on and off position like this, auto throttle arm off. We have the LV nav ready. We can disarm by disconnecting the flight director. So we need the flight director on, flight level change. We have the airspeed. Here we can set. Also the autopilot disengage like this. The heading 136 degrees over here. Vertical speed zeros, level off, descent like this, or climb like this the other way. Also the altitude we're gonna set thousands, 35,000s and hundreds. So now we're ready to go for takeoff. So this is Thomas Hatsios, German America Alpha and the Boeing 77. We go now for takeoff. We start the taxi into the runway. So we advance the thrust levers, parking brakes off, and take the clearance from the air traffic control. So we align with the runway center line over here, as you can see. So we use the tiller like this to align with the center line, as you can see. So this is Thomas Hatsios, German American pilot flying the Boeing 787. So thank you for watching. I'm just starting the flight of the Boeing 787, so stay with me. I will fly takeoff, climb, cruise, descent, approach and landing the Boeing airplane. So we start now, advance the thrust levers to 60% and align with the center line. Stabilize the engines first, 60% like this, then higher for takeoff. Go around thrust. So we press the side stick down until 80 knots. Also align. We have some side wind. So we have 120, 130, V1. We rotate and V2, as you can see. So we have the positive rate of climb. Landing gear up like this, as you can see. So we have the takeoff over here, as you can see. So we keep climbing. You can see all the instruments of the Boeing airplane are correct after takeoff. So you can see here we have the terrain, red, green, yellow. You can see the airspeed 230 knots. The altitude we are 2,400 above the ground, but 4,200 above the sea. We climb with 5,000 feet per minute right now. So you can see more of the terrain, red, green, yellow over here. Further away, some mountains are in front of you as we're climbing. Also, you can see the weather. We have also the flight plan. You can see the wind direction over here in speed. Also, we have in a closer view like this, you can see as we are climbing. So as we climb, you can see over here the aircraft symbol is like 5,000 feet above the ground right now. So you can see the terrain below us. This green line is the terrain. You can avoid if you have low visibility. You can see around and below as we fly through this altitude. So now we're gonna make the turn over here. You can see the Switzerland. Very we start the turn to follow the flight plan as we climb. So this is the view of the cockpit as we're climbing the Boeing 787. You can see we can leave the hands off from the side stick, no problem. We have no autopilot yet connected. So we need to follow this purple line as we turn, usually a bit left rudder to make it faster. and more coordinated turn. Also you saw this view here. You can see the whole flight plan from this side over here as we are flying. So this is all the flight plan we have to fly through with the aircraft to make some turns here and come back for landing. You can see both sides. Keep climbing over here, have some overspeed. So we have Mach 059 right now, our airspeed, half Mach almost. So make a turn here. Again. So you can see the Boeing 787, beautiful view. So this is the Switzerland, Swiss Alps and Zurich. And we're going back to the airport in a couple of minutes. We have to fly through some waypoints here. You can see also an aircraft that we just spotted over here. You can see the Zui here is the waypoint we need to follow. After the intercept is 3.5 nautical miles away. So we're gonna override the intercept. We're gonna fly through straight to Zui like this. So this is the Boeing 787 as we're flying here. So this is very beautiful view of the airplane, as you can see. And our galactic view of the star sign. So now we fly straight out to Zurich. As you can see in the primary flight display, the airspeed, the altitude, vertical rate of climb descent. Also the flight director, the wind speed. Over here the altitude above the ground, we are almost 20,000 feet. As you can see the aircraft symbol here in the vertical display. So we need to make the turn now. And we have the next waypoint here is the Negria. So right turn, and use right rudder pedal for the right turn to make it more smooth and fast. Gonna increase the airspeed like this, as you can see. So here is the alignment, the flight plan, this purple line over here will be aligned with, you can see how we fly manually. You can see the flight controls, deflection over here, also climb, descent, and the horizontal tail trim stabilizer trim over here. So now we're flying straight over the flight plan, which is good. You can see the Negria is the next waypoint we have to fly over. It's 19.1, 18.9 nautical miles right now, 18.7. Keep flying closer and closer. Maybe use a bit more idle thrust because we're gonna make some turn now. You can see also the other side, the flight plan view. So we have to view more as we're climbing. We have to follow this line, as you can see over here. So this is the furthermost waypoint we need to fly through, the Negria. Over here, this is the aircraft, so we fly straight to it. Then we're gonna make a turn, go back to Matif, Amity. As you can see also the waypoints we follow over here from the flight management computer, one waypoint by another. So we're gonna override the waypoint later. So this is also the view. from the outside. I'm gonna make the turn now. So this is Germany, my homeland over here, the lakes, also the France and the Switzerland. So we're gonna start the turn now. Over here, start manual turn. Also use right rudder for this turn to make it faster. You can see we make manual flying, overriding. The waypoints, you can see all flight instruments are correct over here in the displays, and use right rudder for the turn and right aileron. So you can see the flight plan, we're gonna override the waypoints here, couple of waypoints, and we go back. We're gonna connect also the autopilot if we have some time later. So here we're flying over. You can see actually how we overflying Germany here, Bayern Munich, my homeland, Germany, and Switzerland, and also the France over here. Behind us also we have the frozen vapors, the chemtrails of the Boeing airplane, like this, as you can see. So this is very beautiful view. So we're gonna make the turn, overflying the lakes, beautiful lakes here of the Switzerland. Will be aligned with the flight plan. You can see we leave the hands off, no problem. Still have no autopilot connected. We're gonna use a little bit more right rudder to make faster the turn and adjust the flight path of the airplane. So we need to nail in the aircraft trajectory into this purple line as we fly to follow, connect the autopilot correctly. This purple line is the flight plan line from the flight management computer. So you can see we have the Swiss Alps over here, beautiful view. We have all indications are correct, and we can connect the autopilot. You can see now we still have flight director over here. So in order to connect the autopilot, we go over here, we press auto throttle left and right on, and also autopilot on. And now we have to override a waypoint now because the autopilot is gonna follow. So we need to follow straight to Zui over here, as you can see. Press the execute like this button, and we're flying straight to Zui right now, as you can see. So now it's gonna follow the correct flight path as we connected the autopilot. Also it's gonna climb a little bit. So here we are, have the chemtrails. So we have this Germany, my homeland, behind you, in the France, the Switzerland, beautiful view, and also the frozen vapors, the galactic view of the Boeing 787, as you can see. So this is a very beautiful galactic view, as you can see. And we are connected with the autopilot. Now we fly straight back. You can see the cockpit view as we have the autopilot connected of the Boeing 787. So everything correct inside. All instruments. Also we need maybe use a little bit more, less flaps over here. Retract the flaps, and we're gonna increase the airspeed like this. So you can see the autopilot follow up, autopilot connected, and it's gonna follow next waypoint. Zoo is 1.1 nautical miles away from us. We fly straight to it. You can see the engine thrust right now. There's many indications. So the autopilot is connected here with the LNAV and the altitude. So next waypoint is Zurich 701 right now. We need to start our descent like this. You can see autopilot also over here in the head-up display. So we start the descent now. Over here we have the altitude. This is a lower altitude like that in thousands. And also vertical speed like this. Descent. I'm gonna descend with minus 6,500, and this idle thrust for descent like this. And so this is the descent. Now we are descending the Boeing 787. You can see we fly with the autopilot like this on. So the aircraft manages the flight path automatically from the flight management computer, and the indications that we have selected the settings. So maybe we're gonna use some speed brakes here. You can see with descent. So you can see here also the chemtrails we left behind. Switzerland, France, and we're going back. So you can see here we have selected from the autopilot panel this airspeed, this vertical rate of descent, and this altitude, target altitude. So this display, the navigation display, will show us in the map where the aircraft is gonna descend actually following this rate of descent, minus 6,500 feet, this altitude and the airspeed target. So you can see it's gonna be this green arc point over here. This green arc is the descent or climb point based on the autopilot settings or base flight manually the aircraft. So you can see also some other waypoints following here as we are descending. Autopilot keep connected. We have also some, you can see some scans from the radar like this. So we're gonna disconnect the autopilot now like this and follow manually the rest of the flight plan as we are descending using idle thrust and speed brakes extended. You can see auto throttle left and right off, autopilot reset. We keep descending as you can see. So we're gonna make a small turn here for approach and landing. Gonna keep descending. So we start the turn manually as you can see. So we have blenders here as you can see. The data for following the flight path going back to the airport as you can see. So this is the turn. We're gonna make a small turn using the rudder, left rudder, make faster, more rapid turn. Maybe use sometimes some thrust like this as we are descending. You can see manual flying over here, manual input. So we're leveling off 7,000 feet, use a little bit more thrust over here. It's gonna help us nail in the airplane into the flight path, correct flight path over here for approach and landing. So keep descending 6,000 feet. You can see the terrain here. When we go into a cloud like this, we have minimum visibility. We can follow these here indications. So we can make zero visibility approach and landing. Cut 3 Lszh localizer. As you can see, use a little bit less idle thrust and landing gear down as we are descending. Also some flaps over here for approach and landing. This is gonna give us the outside view as we are approaching. So we have the correct flight path right now. Use the rudder pedals over here and the ailerons to align the airplane like this, as you can see, as we are descending for landing. So we have the runway over here. We have the Lszh localizer also. We can align the horizontal localizer and the vertical glide slope of the angle of approach. So we have some, you can see indications here. You can see also the vertical over here, the Lszh localizer, the airspeed, the vertical rate of descent, and the information. So we add some thrust over here as we are descending. So we have some side wind, some wind gust we need to follow. We need to align the airplane with the side wind and the wind gust, as you can see, because we have snow falling. So we're gonna use cross controls, cross ailerons and thrust and rudder pedals. So we are approaching for the landing. We have a few more seconds, as you can see. So we are in a very good position. Keep using cross controls because we have some wind gusts, side wind. Use also flaps 30 degrees over here. So we are very close for the landing, as you can see, aligned with the center line. We're gonna be flaring also the aircraft. We need 2 red and 2 white over here for alignment with the center line. Also for the angle of approach and landing. So we're gonna be flaring the airplane here. So this is the flare, very beautiful flare and touchdown, very professional, very smooth. So use parking brakes, idle thrust and thrust reverse thrust over here. So we are aligned with the runway center line, very beautiful. As you can see, very beautiful slow down, very professional. Keep slowing. So we made it, very beautiful, very professional. You can see a landing gear part over here. Every tire is safe, there is no breakage. Over here also the nose wheel, made very smooth, very beautiful. Landing, the airplane is starting up the way it should be in the runway, very safe. You can see nose wheel here, there is no breakage. Also the tires behind, no breakage. Very smooth landing actually, even though we had side wind which pushed the aircraft to the side. So you can see also around you how much runway we have available. Also the airport here, the Zurich. Also the thrust reverse. You can see thrust reverse, idle thrust like this. With this arm the thrust reverse, you can arm it, and this arm like this, as you can see. So this is the thrust reverse arm over here. You see reverse thrust displayed, and you see everything inside the cockpit is safe, like this. Also the autopilot. So that was Thomas Hatsios, the German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport back to Zurich International Airport. Thank you very much for watching me. I'll see you next time. Bye bye. We just made a very beautiful flight with the Boeing 787-900 aircraft from takeoff, climb, cruise, descent, approach, and landing, using also the autopilot of the Boeing 787, and we made a very smooth manual landing with the Lszh localizer connected. It was a butter landing, very smooth, so you're gonna see it also in the video. Thank you very much. I see you next time. Bye bye. So I'm gonna show you a little bit more the cockpit, one last view. Show you the walk around. You see the overhead also. Everything is safe. Also the flight management computer. The thrust levers. All controls are working like this here. As you can see, rudder pedals. And our last walk around like this. See the airplane. The way it should be in the runway position, as you can see. No breakage, no broken wheels, no broken tires. Everything is safe as it should be. So I'll see you next time. Thank you very much. Bye bye.